Okay, question 5 is an integration question. It wants us to find the area underneath this curve here. But at this point here at 7,5, it changes from being the curve to this normal here. We know that coordinate's 7,5, so at the moment we know that that's 7 and the height of this triangle shape is 5. What we need to know is the other two places the graph hits the x-axis. If we know this point here, we can work out the integral from here to 7, and if we know this point here, we can find the area of the triangle and then add those two bits together. So I'm going to do I'm going to deal with the equation of the normal first to get that point. And to do that, we are going to differentiate the function so that we know the gradient function. And if we differentiate this, which we can write as 4x minus 3 to the half, then we'll take the power to the front, take 1 off the power, and times by the differential of this bracket. So we're going to times by 4 as well. So tidying that up gives us 2 over the square root of 4x take 3. If we now substitute 7 in, we will get the gradient at this point here. The gradient of the tangent line, that is, though. Oops. The gradient of the tangent line. So when x is 7, the gradient of the tangent line is going to be 2 over 28 root 25. So that's 2/5. That's the gradient of the tangent line. We want the gradient of the normal, so we want the negative reciprocal of that. So gradient of normal is minus 5 over 2. Now the reason that's useful is because what we know now is we know the gradient of a line and a point on the line, so we can find the equation of the line using y minus y1 equals mx minus x1. So if we now do y minus 5 equals minus 5 over 2 x minus 7, we'll get that, double everything just to get rid of that half. We get that 2y is equal to minus 5x plus 45. So that's our version of the equation of the line. The reason we don't need to worry about the 2 is because what we're now going to do is look at this point, which is when y equals 0. So when y is equal to 0, we can get the x coordinate. So we're going to have 0 on the left equals minus 5x plus 45. So 5x equals 45 and x equals 9, which looks about right from the picture. So this value here is 9. So we can now find the area of that triangle. Let's call that area B and this area A. So in a minute or two, we're going to find the area of B. Next thing to do is find the coordinate here where the original graph hits the x-axis. So that's when this function is equal to 0. So let's do that up here. When y is equal to 0 here, doesn't matter about the root, 4x is going to equal 3, so x is going to be 3/4. So that's this point here. So now if we integrate between 3/4 and 7, we'll get A, and if we find the area of the triangle, we'll get B, and then we can add them together. So we're going to do the area A first. So that's the integral between 3/4 and 7 of the function, which was the square root of 4x minus 3. So this time we're integrating. So we're going to add 1 to the power, divide by the new power, which is the same as timesing by the reciprocal of that power, and dividing by the coefficient of x as well. So that will simplify to 4x take 3 to the 3 over 2 over 2 over 12 over 6. 7 3/4. So now we can put the boundaries in, the limits in. When x is 7, we're going to get that 25 again. So square root of 25 cubed is going to be 125 over 6. And minus, when we put 3/4 in, that's going to give us 0 on the top. 3/4 of 4 is 3, take away 3 is 0. So actually the area of A is just 125 over 6. Area of B was that little triangle. So we had it between 7 and 9, and it had a height of 5. I've drawn it the wrong way. 7, 9, and a height of 5. So the width is 2. So we've got 5 times 2 over 2, which is 5. So then the total area of the shaded region is going to be 125 over 6 plus 5 or plus 30 over 6, which is 155 over 6.